follicle. This lowest part right here is called the follicle bulb because it's kind of enlarged. And then we have coming up into the interior of it at the base these little blood vessels, and that little indentation right there is called the hair papilla. And that's where hair itself cells are formed. And as they are formed by mitosis and they get pigmented, then they're just pushed to the top and then they die off. It's kind of like the way it did in the skin. But the hair itself, the root's just the central part, and then the rest of this is the wall related to the hair follicle. All right? All right, so anyway, again, looking here to show that, again, the follicle basically derived from the epidermis. Again, the enlargement down here is the bulb, and then we have the hair papilla coming up here from the bottom. Cell division right here, you can see the little deals representing the presence of the melanocytes. Again, put melanin into the hair. Several different pigments actually involved right here for hair coloration. But ultimately, again, whenever you have a turn, the pigment initiates right there. And also showing on this one that there is a kind of outer layer of connective tissue around the whole thing that kind of helps support. All right, when you look at the cross-section of the follicle, all of this is the follicle wall right here, and just this little part here on the interior that is the hair itself. Okay, and again, down at the bottom, this is the bulb, the whole enlarged, kind of rounded deal at the base, but again, we've got the little projection to the interior. Hair papilla, of course, different from dermal papilla. That's up at the epidermis. Hair papilla in the base of the hair follicle and the follicle bulb. Again, blood vessels come in here. That's where mitosis occurs to generate hair and produce the length of the hair. And you can see again melanocytes right there. All right, and then otherwise we have sebaceous glands, which we'll say another word about in a second. But sebaceous glands are an exocrine sort of gland. Remember, that means they got a little tube. It's going to secrete the product onto a surface. And so the sebaceous gland shown here in sections. So the secreting parts of the gland are down here. Here's your little tube right here. And then we're putting this oily material, sebum, on the surface of the hair. That's our surface. And then, of course, the hair itself has some degree of oily characteristics to it. We're all different with that. Just reflecting how much of this oily material is actually secreted into the hair follicle. Okay. Another thing we have here is the erector pili muscle. And so this muscle right here, smooth muscle, this is responsible for goosebumps. All right. And so whenever you get frightened or cold or otherwise kind of something weird happens, you often feel goosebumps. Right? Everybody knows what they feel like, right? They're never an individual goosebump, but it's a whole field of hair follicles in one region, all of a sudden, going from this kind of like sort of leaning, kind of relaxed position, this thing contracts, pulls this way, everything pushes up straight up. And you get that little pucker around the follicle. It's part of your sympathetic nerve response, actually, to potential, dangerous situations.
Does mitosis in the hair ever stop?
Well, yeah, unfortunately. Unfortunately, particularly for dudes, right? Yeah, it does. Blame your moms, you guys, matter of fact, if that happens to you, right? Women can have some issue, but it's not nearly as significant.
Yeah, I've just heard a lot of people say, like, my hair hasn't grown in years, it's always been this length.
Yeah, well,
Yeah,
I mean, I don't know, mitosis can slow down. I mean, the older you get, it is going to become slower, right? But as far as absolute hair loss, it's really a guy problem, luckily for most of you, right? And in some cases, women will have thinner hair. Oh, by the way, they estimate you lose about 100 hairs a day, right?
I believe that.
If everything's working right and replaced, right, but
I feel like a dog sometimes.
so anyhow, later on when we talk about the sympathetic nervous system, which is your fight or flight response to danger, goosebumps come up again because that's kind of your body sensing the problem. You're kind of getting all like hyped up to fight or flight.
Okay, no, you answered my question, because like when someone sings really good, I get goosebumps, you know, so that's why I wanted to.
Say it again now.
When someone sings or something like really good, I get goosebumps and
You do,
sing.
well, again,
Hype,
that's the
so.
emotional side of the sympathetic, right? You know?
Right.
We don't normally exactly think too much about them happening then, but, you know, at the same time, you know, it's been happening then too. But anyway, it's not one hair follicle, clearly. It's a whole field of hair follicles all doing this at the same time. And by the way, in a cat's walking around, hair all like relaxed, and all of a sudden the dog shows up and they're like, boom. You know, that's cat goosebumps right there, right? You know, same thing. Hair follicles all kind of responding to the rectus muscle.
My brother threw my cat. He picked up and he threw it.
All right, last thing let me just mention too, and this is one of the things that I find to be absolutely kind of cool. Every single hair follicle that you have, and you've got thousands and thousands and thousands of these suckers, right, have their own individual connection back to the nervous system. So you see this little like array of nerves right there. Okay, that's called a hair root plexus. So every time something touches that hair up there on the surface, a little vibration, no matter how intense or light it is, goes down the hair root, and it causes a bit of movement in the follicle that will be detected by your nervous system. So it will know which hair moved, where it is on the body, how much it moved. And you can test this yourself. Just barely touch that hair. I can feel it. Don't press it, just touch it. You touch over here, and you'll see the signals you sense coming from different places. That's what allows you to detect the bug walking across your head. Ever happened to you? You know, the bees lands on your back or something, you know? Or a piece of what? Debris falls and you're walking around with a big leaf sticking off here, right? You know it's there. You feel the wind blowing your hair? Yeah, hair root plexus. I find that to be really cool, actually. Because all the follicles we got, all the hair we have, each one has its own unique connection back to the nervous system. So if it moves, your brain knows where that movement is coming from, right?
What if you feel something that's not actually on you?
Well, the wind will blow you. Your hair, is that what you mean?
Like, I don't know, like sometimes I feel like there's a bug crawling on me or something and I look down really quick and it's
No,
nothing.
that's sort of a anticipated kind of response that you're sort of anticipating ahead of time. Yeah, that can happen for sure, right? It's like third eye maybe kind of thing, sensing something getting ready to happen, sorry.
Is that why it hurts to pluck hairs?
Yeah.
Is the plexus the reason that it hurts to pluck hairs?
Oh, yeah, yeah, in addition to your pulling, of course, the dermis tissue too. There. Oh, yeah, yeah. All right, well anyhow, so that's hair movement. Now let me say a couple words about our glands right here. Oh, by the way, again, hair section, cross section, round hair straight, kind of oval shape, is more wavy, real flat, kind of more super curly. And then you can also see pigmentation. It's more than just melanin by itself that contributes to the pigment, but if you were to take your own hair, knowing what your hair blood character is, and you cut it in half and look at it as a scope, you should see a cross-section that kind of reflects the way your hair is if it hasn't been manipulated somewhere or another, right? And then anyway, you see older grandma hair, they kind of lose the interior, that's why they lose all their color. Here's showing the hair coming out of the surface of the skin. So all of like the skin kind of being kind of what damage as it comes out. The cuticle on the hair kind of just puts overlapping little tissue layer, almost like shingles on a roof. It basically helps, of course, keep it waterproof. All right, and then let me say again, exocrine gland means that they produce the product in the gland and it ends up on a surface for function. So sebaceous, I just mentioned a second ago, so sebum as a material goes out here onto the surface here of the hair. The sudoriferous glands, there's three basic kinds. There's the eccrine sudoriferous, the apocrine sudoriferous, and then we have our earwax glands here in our ear called ceruminous glands. And so the main one is the eccrine, and you can see on the illustration here, just like on our model, a coiled tube down at the bottom, part that produces the perspiration, and then we have again a tube that leads out here to the surface of the skin. The apocrine, I spelled that one wrong, it should be apocrine, is a modified pseudorypherous gland that does not produce perspiration, but rather is going to be something that does become functional at puberty. And you can see underarm, axillary, pubic region for this. Thought by some people to be kind of a pheromone-producing gland that what humans produce. Because at puberty, clearly you're coming into your reproductive prime, beginning prime of life for reproduction, right? And so some people think that, you know, these apocrine glands produce these kind of subliminal signals, you know. Well documented in insects, well documented in other kinds of animals as sexual mate attractant deals. We never think of ourselves in exactly the same way we would like a moth or something like that, but in the end, you know, again, quite possibly it is a sexual attractant. They don't really have any other good hypothesis for it, or at least to me, right? So it sort of makes sense. But again, they do not produce perspiration, okay? And remember on the model in the lab, it's just that big model that's got that big yellow deal right in the very center of it. Looks like a blown up sweat gland. That's the apocrine gland. And then otherwise, earwax. Okay, so ceruminous gland. So secrete cerumen, earwax into the ear canal. Okay, so we'll be seeing this view here as we talk about hearing. But, you know, again, there's a bunch of hair in there that help to keep bugs and other kind of debris from getting back up into the eardrum. Eardrum located right there. Obviously, we got a little bit of a problem right here. You know, you can get way too much, and that, of course, will cause a lot of problems. But again, they're only found, of course, in the ear canal. And again, it's part of that, trying to keep debris away from the eardrum, which is right at that point right there. All right, and then let me just say about the nails. All right, so protection for the fingers and toes, help pick up objects, help you to scratch yourself. Composed again of dead keratinized cells. As you look at this, remember using your own nails for the laboratory. The body itself is the main part right there. Free edge is the part that goes past the end of the digit that shows the growth. We've got the lunula at the base of the nail. This is much thicker here than it is right there. So this shows actually blood vessel showing through right there, kind of pink color. Much thicker right here, so you don't really see the blood vessel. Remember, the cuticle is called the eponychium. And you do need to be able to spell that on the lab practical if I'm asking you about that. So that's a little sealing band around the edge. And then otherwise, the nail itself produced back up under the skin. So here's the cuticle in the body there, but you continue back up to the interior. We've got what's called the nail matrix. And then that gives rise to the beginning of the nail root, and that's where the cell division and all that occurs to increase the length of the nail. All right, so anyway, we'll stop right there. All right, does anybody have any